So welcome to FACT's webinar called Scaling Up Pastured Livestock Production. Our presenter today is Franklin Egan with Pasa Sustainable Agriculture. This webinar is hosted by Food Animal Concerns Trust, and I am Larissa McKenna. I'm FACT's Humane Farming Program Director, and I'm going to be moderating the session today. So welcome and thanks for being here. Let me take a minute or two to do a few quick introductions before we dive right in. Food Animal Concerns Trust, or FACT, we are a national nonprofit organization. We're based out of Illinois, and we work to promote the safe and humane production of meat, milk, and eggs. So I direct FACT's Humane Farming Program, and I work with farmers all across the country, and we offer a variety of services, including grants, scholarships, personalized materials, mentorship program, and of course, free webinars like this one. So I invite you to visit our website to learn all about our other farmer services. And we do have a lot of really good stuff that's coming up this fall and winter. So at this time, I'm really pleased to introduce our presenter, Franklin Egan. Franklin leads the education and research programs at Pasa Sustainable Agriculture. He holds a PhD in ecology from Penn State University. He's led research on a variety of topics, including biodiversity, conservation on farmlands, environmental risks of GMO crops, and soil health. Franklin has worked as a research ecologist for the USDA Ag Research Service and is also on vegetable and dairy farms in New York and Wisconsin. So we're really lucky to have Franklin here with us, and I think without further ado, I'm going to turn the floor over to him so that he may begin his presentation. So Franklin, please take it away.
Great, thanks so much, Larissa. Really appreciate the invitation and the opportunity to talk with you all today. I'm going to just turn my camera off now that we've said hello and focus on my presentation. So scaling up pastured livestock production. I'm hoping today to present kind of a big picture, step back, 10,000 foot view look at what it might take to scale up pastured livestock production in the U.S. to make it a more mainstream and ubiquitous part of our agricultural system, and what some of the implications of that scaling up would mean for the environment and for our food supply. Before I get into it, I just want to tell you a little bit about Pasa Sustainable Agriculture, the organization I work for. We're a farmers organization based in Pennsylvania, but active throughout the Mid-Atlantic region. We're really driven by providing lifelong professional development for sustainable farmers. So we do a lot with farmer-to-farmer exchange, with events and mentoring and conferences to help farmers come together to learn from each other in terms of, best practices, business strategies, and just, support and social networking. We do a lot with beginner farmer development. We run 2 registered apprenticeship programs for training new farmers in a earn while you learn formal apprenticeship framework, one for dairy farmers and one for vegetable farmers. And we also do a ton with farmer-driven participatory community research. So we work with our farmers to benchmark their sustainability, to look carefully at measurable indicators of sustainability, including profits, soil health, environmental impact, and use those benchmarks to drive learning and insights and improvements. And so I'm going to tell you about some of those benchmarks that we've collected for pastured livestock farms and their land and feed efficiency and their environmental impact as we move ahead today. So just thinking about the big frame, I'm sure this is not a surprise to anybody on the webinar, but globally, meat production and meat consumption has an absolutely huge environmental impact. This is a graphic from a 2010 study in the Proceedings of the National Academy of Sciences. I think if you were to look at an updated 2020 version of this, the situation is probably worse, but this is a really evocative and I think eye-popping graphics. So we've got 3 meat thermometers here for some pretty important global indicators of sustainability. We have greenhouse gases, biomass harvest, so the total amount of biomass that humans use, and nitrogen pollution in terms of global nitrogen pollution per year. And this graphic shows us, with the little red triangle, a generally accepted sustainability boundary. So how much of these indicators we can, push and still have a livable planet. And then there's other dimensions of just what meat contributes to humans' impact for these indicators. So the longer pointed arrow is UN projections for where meat production would put us by 2050. If we can continue on our current path. And then we have some other scenarios presented, like a livestock scenario where we get all of our protein from livestock, a situation where we would substitute beef with more chicken, looking at the 2000 baseline, and then a soy protein or vegan scenario where somehow all of the world's population stops eating meat and gets all of our protein from legumes. And so the takeaway message from this graph is that, again, meat production and consumption has a huge impact. For meat alone, by 2050, we'd be pushing up against the limits of our greenhouse gas emissions, to say nothing of, industry and transport. We'd be harvesting most of the biomass that we can sustainably harvest, to say nothing about other foods or forestry or paper. And we'd be well over our bounds for nitrogen pollution. Some of these other scenarios, like substituting beef for chicken, help quite a bit, and switching to soy protein would really help, according to this study. But I think, of course, it's very unlikely that we'll see a wholesale, uniform transition to vegetarianism. And maybe that's not really fully desirable, right? So there's a lot of good reasons for eating meat. Certainly, just about every cultural and culinary tradition in the world has meat, and animal agriculture is, a core component. Humans like eating meat. Meat is delicious. Animals are very, very useful in agricultural systems for helping to build soil and cycle nutrients and provide sustainable soil fertility. And also, there's definitely an argument that by enabling us to capture waste products and to digest perennial forages in the case of ruminants like cows and sheep, a certain amount of animal agriculture might actually allow us to produce more food with less impact. So the question is, what's the right amount of animal agriculture, and how should we do it? While keeping in mind these really, eye-popping global constraints in mind. So I want to tell a couple stories today from research projects we've been conducting at Pasa. The first one I want to tell you about is land and feed efficiency benchmarks on pastured meats. So, a lot of sustainable farmers are well aware of these challenges with animal agriculture and think that a big part of the solution is producing them on pasture. So grazing systems for ruminants and raising monogastrics like pigs and broiler chickens outdoors in more sustainable and humane practices. One of the farms we work at with Pasa, North Mountain Pastures, it's run by a really talented and I think forward-looking farmer named Brooks Miller, shown here. A few years ago, when I was first starting out at Pasa, he and I got to talking, and Brooks was really curious about just how far he could push the model of production that he practices, in a big picture way. So he distributes a lot of his meat through a CSA model in suburban DC, and had been talking with customers and gotten really thinking about, given the price points that pastured livestock are at, is it really possible to scale this model up and have it be a more ubiquitous part of the food system? And so to get at that question, it's really essential to look very closely at the land and feed efficiency of pastured livestock systems. So how much land and how much feed does it take to produce a unit of meat, raising meat on pasture? And just as importantly for a small business manager like Brooks and other farmers, where are the opportunities to improve efficiency within the pastured system and improve profits and cut costs? And so with that in mind, we started out back in 2016 designing this project where we were working to bring other livestock farmers into a benchmarking group where we could collect statistics on how these farms were doing in terms of the land and feed efficiency of their animal systems, to think not only about the potential to scale things up, but also to cut costs and drive efficiencies for those individual farm businesses. So if you're interested in this, we've got a recent report up on our website. We've also got a spreadsheet where you can download and benchmark your own farm. But essentially what we do is we take some pretty readily available numbers that a lot of farmers will keep in terms of how many animals they're processing a year, and then also what they're feeding those animals in terms of acres grazed as well as imported hay or feed that they're buying. And we take an annual time step approach where we look at the full year of production, but also everything that's needed, not just to produce the animals that you're harvesting, but the background animals that are breeding and sustaining the herd or the flock, and also any animals that are being brought into the farm. And so with that in mind, we've got kind of two numbers we look at. We look at your gross meat yield, which is just how many animals you processed, and typically translating a hanging weight into an estimate of bone-in meat yield. And so just for instance, on this beef farm, as an example, if you had 13,000 pounds of total hanging weight from, say, 25 beef cattle, you take an estimated 65% ratio to get to your bone-in meat yield of about 8,400 pounds. But then we also look at adjusting some of the embedded meat that comes in the form of stockers you buy into the farm, as well as any stockers you might sell as live animals. And so that's this adjusted meat yield where we adjust that gross meat yield by taking into account, in this case, say, 3 stockers that were purchased into the farm weighing 300 pounds live weight at the time, and then also incorporate in, say, 6 stockers that were sold to other farms at an approximated 500 pounds. And so that gives us a sense of the farm's total meat output, and then we can also look at how many acres were grazed, how much hay was purchased to get these land and feed efficiency benchmarks. And so what did we find? Well, so for beef cattle, we were able to work with a total of 6 farms that had good statistics over 2016 and 17. And we've got these 2 very key benchmarks in terms of your meat yield per ton hay, and then the meat yield per total perennial acres. So that's the grazing land as well as the land used to harvest hay. And I think what's really eye-catching about these benchmark tables is that there's a tremendous amount of range and efficiency in just this small cohort of Pennsylvania farmers. So Farm A is at the kind of the top of the curve, getting 164 pounds of meat per ton hay and a total of 71 pounds per acre of land, whereas the lowest performing farm is less than half that at 31 pounds. And so there's a tremendous amount of variation in this little group, a tremendous amount of variation in practices, and also a lot to be learned as you get these farmers together and start sharing and really looking under the hood of what might differentiate these different efficiencies. And in some cases, it has a lot to do with maybe just the land base and the quality of the soil and the productivity of the grassland. Has to do with genetics and the breeding animals. It may have a lot to do with just the experience and intention and skill of the farmer as a managed grazer. And so this information is designed to help us look at land efficiency, but also really to drive conversations and peer-to-peer learning among our farmers. We've got some similar statistics for pigs. So here we look at meat yield per pound of feed. And we have, again, a range between, in the highest case, 16 hundredths of a pound of feed for 1 pound of meat, or I'm sorry, I have that reversed, all the way down to a lower score of 8 hundredths of a pound of meat per pound of feed. And that translates into some very different land use efficiencies, where our most efficient farm is able to produce nearly 1,200 pounds of meat per acre of total cropland used to raise the grain for these animals, down to a low score of only 313 pounds per acre. And so again, there's a lot of learning and knowledge transfer and opportunities to improve efficiency in just this small group of farmers, many of whom did not really have a good handle on what their efficiency was for, again, kind of this core metric of meat yield per pound of feed. And we found in many cases, feed purchases were like 30% or more of the enterprise budgets for the pigs. But farmers weren't necessarily reviewing or looking really critically at that efficiency consistently. Broilers, we had a lot of farms that produced broilers, but very few that were able to actually give us the statistics we needed. And in that case, often what was happening is we had farmers that produced a mixture of poultry, broilers, turkeys, layers, but at certain points in the production cycle, we're choosing to kind of feed all of the animals from the same grain bin. And so we're unable to separate out costs by these different animal enterprises, being broilers or turkeys or layers. And so there was a case where you have a sort of a day-to-day, logistical reason for doing things one way that would really prevent the farm from being able to accurately estimate their costs of production and their efficiencies in production. Again, we saw a pretty huge range in efficiency for feed. In the broilers, we had one farm that had really eye-poppingly high efficiencies that honestly I don't think were totally accurate, but point to really some of the challenges and the need for improvements in record-keeping systems on a lot of pastured livestock operations. But as a typical benchmark, we found anywhere from 0.27 to 0.37 pounds of meat per pound of feed. And again, we have the spreadsheet tool used to run these numbers available on our website. Please feel free to download it or follow up with any questions about using it. So what does this all translate to in terms of land use efficiency of the pastured livestock model versus kind of the business as usual confinement CAFO model that supplies most of U.S. meat today? Well, to look at that, we looked at kind of a composite basket of animal products. So thinking about beef, chicken, and pork in proportion to how we typically consume them in the U.S., which is about roughly a third of each type of animal, and looked at how many square feet of land it would take to produce a pound of that basket of animal products on the pasture-based systems that we found with Pasa farms versus some industry standard confinement systems. And we looked at land as not just total land base, but looking at the perennial land used to graze the cattle and pasture broilers or pigs in the case of the pastured systems, and then also the annual cropland used to raise feed. It's really critical to look at both of these and both of these separately because one, annual cropland is in much shorter supply nationally and globally, and also the environmental impact of annual crop production is just much, much higher than the environmental impact of perennial crop production, pastures with deep-rooted soil-building plants that are green and growing, and have living roots 365, 24/7. When we look at this analysis, what this figure is showing is that, yes, pastured systems are much less land efficient than confinement systems, but most of the extra land is perennial land. And that actually in aggregate, we found that pastured systems use about as much cropland per unit of that basket of meat produced as a confinement system. And really all of the extra land, quote unquote, would be in the form of perennial pastures and hayland. And so that, I think, is something very important to keep in mind, that yes, pastured systems are less land efficient than our business as usual practices. But again, it's mostly perennial land, which has just a very different picture in terms of its impact on environmental quality. So what does this mean for our ability to scale up feeding Pennsylvania or feeding any land area with pastured livestock? To do that, we took kind of a look at Pennsylvania from a simple back-of-the-envelope calculation approach. Pennsylvania has quite a bit of agricultural land to work with. From our current land use portfolio, we've got about 4.5 million acres of cropland and about 700,000 acres of perennial pastures across the state. We've got a pretty big population, about 12 million people in Pennsylvania. And so if you were to think about what it would take to raise the meat needed to provide those 12 million people with, let's say, for the sake of argument, the USDA recommendation of about 5 ounces of animal protein a day, we can run those numbers taking into account the pastured livestock models I've summarized and the kind of industry standard confinement model. And what we find is that as you would infer from that last slide I showed, with the pasture-based system, you would need a lot of perennial land, some 12 million acres of perennial land. So in Pennsylvania and beyond, you'd be converting annual cropland into perennial land to graze cattle and to provide foraging areas for pigs and broilers. And you'd also need some substantially more annual cropland. The picture for the confinement system would be much different. You'd need more annual cropland than the state currently has, with a slightly expanded footprint of pasture land. And so, again, the take home here is, one, Pennsylvania is in no position anytime soon to be self-sufficient for animal agriculture or any other type of agriculture. So we've got lots of agricultural land, but also, of course, 2 huge cities in Philadelphia and Pittsburgh. But if you were to try and really scale up the pastured livestock model, you'd need a lot more land, but most of it would be perennial land. Okay, so with that, I want to switch gears and tell my second research story for the day with a much deeper dive into pastured-based dairies as one particular production model. So organic and grazing dairies where animals are being fed on grass for a lot of the year. We conducted a study with the USDA about 2 years ago where we worked with an engineer at the USDA Agricultural Research Service named Al Rotz, who has over the past 30 years built a really substantial computer model designed to assess the full footprint of production and environmental impacts of a dairy farm system. So incorporating energy used in growing feed and transporting feed, nutrient use losses and inputs in soil systems, and then production of milk and beef from the dairy farm. And so you can go out and use this model and assay the practices on a working dairy and get a pretty complete and robust estimate of some key environmental footprints of that farm system in terms of its energy use, its nutrient pollution potential, and its greenhouse gas emissions. And so we went out and we interviewed about exactly eight organic and grass-based dairies in Pennsylvania and assessed their range of practices in terms of how they produce milk on the farm. And so this is a table just kind of summarizing what those farms were like. We had really a range of different farms, from some very small ones with just say 26 cows up to some pretty good sized 240 cow dairies, shipping milk to Organic Valley or Horizon. A really big range in milk production. The lowest production farm producing around 2,900 kilograms, or maybe around 8,000 pounds of milk per cow, where some of the more high output farms were doing about 6,700 kilograms, or 18,000 pounds per cow, which is more typical of some of the confinement dairies in Pennsylvania. Just a quick note, we looked at milk production in terms of this acronym here, fat and protein corrected milk. So that's just an attempt to normalize milk that has some different quality components in terms of butter, fat, and protein into kind of a standardized unit. So a range of farm types here. Some of the farms were what we called all grass farms, where everything was forage, so grazing in the summer and then hay in the winter. And then some farms that supplemented grass with organic grains. So what we found in terms of environmental impacts of these dairies, I think is pretty interesting. And so this table here, I'll work through some of the summaries. But if you look at the columns of the table, we've got the all grass farms, the grass with grain farms, and then we pegged that to a mid-sized confinement kind of business as usual Pennsylvania dairy. And so for each indicator here, you'll see we've got a pair of numbers. We've got the impact, for instance, in terms of phosphorus runoff, presented as kilograms per hectare, so per unit area of the farm. And then we also have it presented in terms of per unit of milk produced, so per unit of fat and protein corrected milk. And as you work down these different indicators, phosphorus runoff, blue water use, which just means clean water use, energy use, the reactive end nitrogen pollution or reactive end footprint, and then the carbon footprint in terms of total of greenhouse gases, you'll see that there's this really interesting pattern where when you look at things from a per unit area perspective, the grass farms typically do substantially better than the confinement farms. But then when you look at it from the opposite perspective of a per unit milk production, the pattern often gets entirely flipped, where the grass farms are on par with confinement, or sometimes are polluting more. And so just for example here, looking at the reactive end footprint, our all grass farm produces 65 grams of nitrogen pollution per hectare, whereas the confined one produces 82 grams. But then when you normalize that to kilograms of fat and protein corrected milk, it's totally the opposite. So 2.5 grams per kilogram for the grass farm and 1.4 for the confinement farm. And so the reason for that is actually pretty straightforward. If you remember, we looked at the total milk production per cow, and we find that the grass farms are much less productive per cow. So something around 3,800 kilograms per cow on average, much less productive than the confinement farm. And so on a per area basis, these grass-based farms have wonderful benefits for the environment in terms of much less runoff, much less energy use, water use. But when you normalize it to per unit of production, they don't look normally as efficient. And that's a trend that we've seen in our study, along with many other studies for multiple types of animal agriculture. So similar patterns for grass-fed versus confinement beef production, as well as in the pig and poultry industries. So you've probably heard versions of this argument before. Here's a slide with a figure from an editorial in the New York Times that came out a few years ago that I know got quite a bit of flack and sort of ire from the sustainable ag community. They make this argument that we've heard many, many times before in terms of why industrial farms are good for the environment. And the case goes that, industrial agriculture, confinement-based animal production is just so much more efficient that all told, its impact on the environment is going to be better. So, for instance, this author is summarizing that, if we were to have the same amount of beef output as we did in 2015 with 1950s technology, we'd need something like 34% more animals and therefore 34% more environmental impact, and the same argument down the line for dairy or corn or what have you. And I think, this is pretty simplistic, but there is also, a grain of truth to it that maybe from this perspective, if we're going to eat meat, we should double down and keep forward with industrial ag approaches to try and really drive efficiency and reduce our overall use per unit of product produced. So drive down energy and greenhouse gas production per unit product rather than unit land. And it's, I think, a really pervasive argument that folks that are producing for pastured livestock systems should be aware of, should think carefully about, and think carefully through some of the counter arguments. And so with that in mind, I want to take a step back and think a little bit about what it really means to be measuring and evaluating the efficiency of livestock systems. Okay, so with that in mind, I want to kind of switch gears a little bit and like to ask you all a question. Might seem like a pretty out-of-the-box question, but what do you think is the more energy efficient animal? Is it the mouse or is it the elephant? And so there's a poll up, and if you just want to chime in really quickly and share your thoughts there. All right. So, Larissa, did I lose the poll results, or can we bring those up? Okay, so I think it was kind of stabilizing, as I recall, around.
Sorry, I don't know if I can actually show the results, but I can tell you that mouse got 42% and elephant got 58%.
Yeah. Okay. So a clear vote for elephants, although not quite maybe a landslide. Actually, what I would contend is that the answer to that question depends entirely on scale. And so this is where I think it gets interesting, and there's some interesting ecology and biology at play here. So if you drill all the way down at the cellular level of energy use, and think about, how these two organisms use energy at the cellular level, the elephant is actually clearly more efficient. So mice have a really fast metabolism, really high motor. Their cells burn through an estimated 3 watts or 3 calories per second of energy per kilogram of body mass, whereas the elephant is a much slower burning organism, only about half a watt. But of course, elephants are huge and mice are tiny. So at the scale of a individual organism, the perspective is completely different, where a mouse, super efficient, using only about 0.06 of a watt per individual, and an elephant is burning through 2,000 watts. So an entirely different perspective. But of course, organisms don't exist as individuals. They live in populations of interbreeding animals. and mice tend to be really dense out there in the landscape, as many as 10,000 individuals per square kilometer. Whereas elephants are much more sparse, only a few individuals per square kilometer. But because of that difference in body mass, elephants still come out as using quite a bit more energy. But then, of course, it's not just a population. We have roving ranges, and mice are spread out over the entire globe, live basically wherever we have humans and agriculture in a temperate climate, whereas elephants are much more confined to a few parts of Africa and India. And so with that in mind, we estimate that there's like millions upon millions of mice in the world, and that they might be consuming right now as much as 24 gigawatts of energy as a species, whereas elephants have a much lower impact or energy use. So all that was just to illustrate that this question of efficiency is wholly dependent on the scale you're looking at, and also what some of the constraints around scale are. Is the energy consumption and the range of the species scoped around a specific region of the planet, or is the organism able to spread out and use as much as it wants wherever it can find habitat? So yeah, two points here. Resource efficiency is very much a scale-dependent question, and an increase in efficiency at one scale often leads to greater total resource use at a larger scale. So yeah, connecting the somewhat abstract analogy back to agriculture and pasture-based dairies, I think I would argue that, confinement dairies are kind of like the mouse in this analogy, where they're more efficient at the scale of individual farms. But because you can remove this key constraint of not just being reliant on a local land base, but being able to import a lot of grain and forage, you get a greater total land and resource use when you think about the industry as a whole, either regionally or nationally or global. Whereas pasture-based dairies, and maybe by extension pasture-based livestock, is more like the elephant. So it's less efficient at the scale of an individual farm, but because you retain that constraint of needing locally available grazing land, and in fact you're really embracing that constraint as part of sort of the ethical foundation of that system, you've got less total global land and resource use for that scenario as a whole. And so with that, I want to kind of wrap up by tying into, I think, this very powerful concept out there called default meat consumption. It's also been called kind of I think the term is the ecological leftovers model of meat consumption. And I first saw it spelled out in this really wonderful, wonderful book called Meat, A Benign Extravagance by Simon Fairley. And basically in this book, he makes the case for a level of animal agriculture that he calls default meat consumption. And so the idea here is that if you look at the environmental impact of animal agriculture and its relation to the amount of meat that people are consuming, it's not a straightforward linear relationship. And so up to a certain point, animal agriculture actually has a fairly limited impact on the environment, as we're mainly raising animals on pastures that can't be used for other types of agriculture. We're raising animals on forages that humans can't eat directly. We're incorporating animals into crop rotations to therefore enhance grain production. And then we're feeding, the monogastrics like pigs and broilers, mainly waste products. And that's, how humans did animal agriculture for much of our history. But when you get beyond a certain point and start intensifying animal agriculture and feeding animals in confinement and producing crops that could be fed to humans and feeding them directly to animals, the environmental impact starts to really take off. And that's the situation that we're in today. And so with this argument in mind, the key is to impose some kind of constraint on the scale of meat consumption, where we're grazing on lands unsuitable for arable crops, we're feeding forages so that we can build soil, and we're feeding animals waste and byproducts. And I think scientists are kind of looking at this more and more carefully. There's been a number of assessments of what the level of default meat consumption would be. There's a lot of variables in play in terms of, what's the scale of analysis for a region or a country, what's the population level, and what's the exact mix of animal products. But the range of estimates is that would be between 7 and say 36% of current U.S. animal protein consumption if we were to have more of a default meat model. Keeping in mind that the U.S. leads the way globally, I believe, in many respects in terms of per capita meat consumption. So, okay, wrapping that all up, a couple of takeaways. Going back to our farm scale assessments, we found that pastured livestock farmers had a lot of variation in their land and feed efficiencies, and there's a lot of room on a lot of farms, I think, to tweak and improve the efficiency as well as the profitability while staying committed to a pastured model. For pastured dairy, and I think for a lot of pastured environmental models or livestock models, we found that environmental impacts per acre were much lower than industry standards, but environmental impacts per unit of product, per unit milk, may be higher. And that we found that, I think the synthesis here is that scaling up pastured livestock, making it the more ubiquitous and standard model of production, would probably mean a less abundant meat supply overall, but much less environmental impacts and a more sustainable agricultural system as a whole. And so with that, I saw lots of questions flying on the screen as I was talking. And I think we've got a little bit of time to hopefully work through some of your questions. So thanks very much for your attention, and happy to talk more.
Excellent. Thanks, Franklin. Yeah, we do have some questions that have come in, and we do have some time here. So what I'm going to do is ask folks, if you do have specific questions for Franklin, to type them in to the sidebar. We'll try to get to as many as we can. Otherwise, there'll be other opportunities for follow-up. And I'll read them so everyone can hear what they say, and then Franklin will try to address them as best he can. So one question that came in earlier in the presentation was when we were looking at the feed efficiency benchmarks, and if they were accounting for differentiating between feeds that are edible to humans and feeds that are inedible to humans, grains versus grasses and such.
Yeah, so in our assessment with our farmers, we just looked at feed overall, and in terms of total pounds. We did break it out into components and looked at the total land needed to grow those components, and that tended to include a mixture of stuff that could have been directly edible, but also some byproducts like distillers dried grain solubles from the ethanol industry. And we used a method of accounting for those byproducts that basically prorates the land used to grow them. And so that was one of the big ways that farms boosted their land efficiency, was by being more reliant on a feed mix that contained more byproducts.
Excellent, great. Okay, and another question that came towards the beginning of our, closer to the beginning of the presentation, did the land use take into account waste generation, such as manure pits, fields? It's already accounted for on pasture.
I'm not sure I totally get that question exactly, but basically our land area was all of the grazing and crop production areas maybe on the farm, but also off the farm to produce crops. It didn't account for infrastructure like barns and manure pits, but I think would have accounted for land where the manure was spread onto for crop production.
Is this land use efficiency comparison between pasture and confinement accounting for the current state of land degradation? I'm speaking from, I think this viewer is from the West, where perennial land isn't anywhere near its optimized carrying capacity. And I know that's might be not the same in Pennsylvania, but.
Yeah, I think basically for that particular slide, we kind of benchmarked the pastured systems to the average from our cohort that we looked at. I think, for the beef systems in particular, all of the farms were practicing managed grazing. I do think there were some of the farms that, definitely weren't getting as much of it as they could have with maybe some improved practices, but probably fairly close to, I don't want to say optimal, but getting a pretty healthy amount of forage out of that land. So not degraded land.
Right. There's been also a couple of folks that have typed in and shared some other resources. So I want to just acknowledge those, and we'll pass along those that are helpful. Another question: what would you say is a sustainable amount of meat consumed per person in the pasture-based system? Maybe the question of the year, right?
Yeah. Wow. I'd like to know the answer to that. I think, let me see if I can go back here. This paper cited here is a review of some of the different attempts that have been out there trying to answer that question. If we were to just kind of say that this default model of, feeding ruminants on land unsuitable for arable crops and sticking to feeding waste and byproducts, they found that there's a range of something between 7% and 36% seems feasible. And again, that depends on the mixture of beef and eggs and milk that you might choose to consume. That translates to, I think it was around 8 to 30 grams of animal protein a day. And I'm struggling to convert that into ounces and servings, but it's less than a third of what the typical American eats today.
It's a big difference. Question: what is an approximate square foot of improved pasture / cropland needed to raise pastured pork and broiler chickens? Or perhaps where might you look to get that information?
In terms of recommendations on sort of stocking density, I think SARE has some great resources on that. Our report also has some statistics on what we typically found. I would say that for the broilers, the actual pasture land area was never a constraint on our farms. Always had plenty of pasturing area for the broilers, typically integrated with beef cattle. The real land use footprint comes from the land used to raise the grain for the broilers.
Interesting. Here's another one. Have you or do you know of someone that's evaluated genetic selection for animals more suited for pasture production based on pounds of production?
So we were not able to look at that specifically. I think there's been a lot of work on that for grass finished beef, and certainly a lot of different opinions and schools of thought over what's best. I feel like pigs and broilers, that's where there's huge, window for improvement is coming up with varieties that do better and are healthier on pasture.
Thank you. So someone's wondering if Pasa Sustainable Agriculture has any plans for kind of like to expand your data set, kind of to kind of fill in the sizes of farms and kind of figure out, the variation where, what might be more of a, the question is, a wide variation among farms and small sample size might impact your conclusions, and just wondering about future research that you guys might be underway or planning for.
Yeah, definitely. This project is open-ended. So I mentioned you can access the spreadsheet tool and benchmark your farm. If you then want to share your numbers for the good of the cause, you can send it back to us and we'll add it to our data set. So we would love to keep growing this project and put out revisions as we learn more. We also have some plans, probably mostly with grass-fed beef producers, to do some more detailed financial benchmarking, where we can get a handle on some of the core cost and cost areas for beef production.
Yeah. So one more question before I kind of wrap things up. Does any of the land use efficiencies account for integrated systems with stacked enterprises in both integrated cropping and silvopasture systems?
Well, so let's see. I think most of these farms, like I mentioned, were kind of integrating at least a few of the 3 enterprises we looked at. So, broilers following beef cattle. None were integrating, well, with the exception of the dairies, but none of the pastured livestock farms, meat farms, were integrating crop production and grazing. And I think that is, something that a lot of people would like to figure out how to do, but currently, at least in Pennsylvania, the economics don't usually work out.
Yeah, excellent. Okay, that'll start this, your takeaways. Let me just have a few housekeeping items before we wrap up. Thank you for taking the time, Franklin, and going through the presentation and all the questions. So really helpful. As a reminder, immediately after this webinar, you're going to be asked to complete a really very brief survey. It's just a handful of questions. So please take a minute to tell us about your experience, give us any feedback, any ideas for the future. We're very open to all of that. Also, recording of the webinar and the slides will be available soon. These documents will be archived on the FACT website, and I'm going to email them all to you later today. A quick plug for some of the other webinars that we have coming up in the next few weeks. It's a kind of a nice follow-up and a supplement to this webinar. On October 7th, Bruce Hennessy from Maple Wind Farm up in Vermont, he's going to be with us to discuss scaling up pastured poultry production. So that should be really good. And then later in October and November, we're going to be hosting a 3-part silvopasture series featuring Steve Gabriel from Cornell. And I'll be sure to send links to those registrations in my follow-up email. So I am afraid that is all the time we have for this afternoon. Again, a sincere thank you to you, Franklin. It's really been an honor and a pleasure to have you on with us today, kicking off our webinar season. I'd also like to thank everyone out there in the audience for your interest and your attention and your great questions. I hope that we're able to connect again soon. Enjoy the afternoon, and goodbye for now. Bye, everyone.
Thanks so much, Larissa.
Yeah, bye.